With the increasing advocacy of clean and renewable resources and the goal of achieving the SDGs, photovoltaic power generation has gradually developed into larger scales. Until 2024, the global cumulative installed capacity of photovoltaic power generation had already reached 2.2 terawatts, with China alone contributing more than 1 terawatt. So, our daily lives rely more on photovoltaic power generation. Through this technology, solar energy is converted into electricity and supports electric devices that we use nearly every day. But here comes the question. If I am an investor who is very positive about the future of photovoltaic power generation industry, when facing so many of them in China, which region's photovoltaic power generation is the most promising for me to invest? So, this leads to our research question for this project. Which region in China has the fastest growth in photovoltaic power generation between 2021 and 2024? In this case, we have to utilize data to help us find the answer. By collecting, cleaning, analyzing, visualizing, and predicting future data, we may find the possible answer to our research question. The first thing we have to do is collect the data. But what kind of data is needed? And where can we find the dataset we need? To find out what kind of data we need, breaking up our research question to find our focus is the most essential part. By highlighting the keywords in the research question, we know that the dataset we need must include those variables in order to be valid. However, where can we find the data that covers them all? Our solution is researching online for multiple resources and combine them together, because it is nearly impossible for one single source on the internet to provide the exact data we need. And then we synthesize the individual internet sources together in Excel into a full dataset that includes variables of 4 years, 30 regions in China, and the corresponding photovoltaic power generation. After collecting the data, the next step is to clean the data. In this part, the questions that we ask ourselves are: what problems does the original dataset have? And could the computer correctly read and understand the data like we did? To check the possible mistakes in the dataset, the most intuitive way was to see if PyCharm, the Python tool, could correctly generate a linear, continuous, and meaningful graph using our dataset. However, when we coded it to let it generate a line plot of the photovoltaic power generation of each region in this 4 years using the dataset we organized, something went wrong. The errors were not in the correct order, and some lines broke apart into segments. Why was that? Could the computer correctly read the data? We checked our dataset again, and we discovered the mistake. For the same variable, the naming was different, so the computer perceived them as two unmatched variables and was unable to connect them together in one single line. As a result, we revised the dataset, changed the naming, and put it into the code, which successfully generates the correct graph. With this graph, we also had an idea of the general tendency of photovoltaic power generation development in each region over 4 years. Then, the third step is analyzing the data. In this part, we wonder what is the change in photovoltaic power generation of each region between years, and which region has the biggest improvement. To see the changes over years, we must analyze the tendency of regions' photovoltaic power generation progress. But how? We need to do a quantitative analysis of the growth rate each year. Also, by using Python, this could be done. First, we need to import the pandas package, which specializes in doing calculations and quantified data analysis. Second, link our dataset into the code. Third, use the unstack tool to reorganize the variables into rows and columns. And fourth, calculate the growth rate of photovoltaic power generation between each 2 years by using the formula. Fifth, sort and organize the data in a descending order of photovoltaic power generation growth rate. And finally, print out the result. The output of this entire process is the growth rates of photovoltaic power generation of the regions between each 2 years, and we organize them into 3 separate charts to compare them together. As we can see, the regions that had the highest growth rates from these three charts are Shanghai, Yunnan, and Yunnan again, respectively. So, by calculating the growth rates from every single year within 2021 to 2024, we can see the progress of every single region and how they have changed. However, to see which region had the biggest improvement in a more general and broader view, we have to stretch the span of time to the whole 4 years to calculate the overall growth rates. So, we coded again with a similar logic from the last one, but changed the calculation of growth rate into comparing the data of 2024 and 2021 instead of breaking them into smaller groups. And then we got the growth rates of each region in the entire 4 years. Now, we can answer the question, which region had the biggest improvement? Absolutely Yunnan, because it had an overall growth rate of about 700% in these 4 years. In 2021 to 2022, it only had a growth rate of photovoltaic power generation of about 6% and ranking the 25th place. But in 2022 to 2023, it had a growth rate of about 140%, ranking the first place. And from 2023 to 2024, it continued to make big progress and had a growth rate of about 213%, also ranking the first place. These are all of our data analysis on the growth rates, and now let's move on to the visualization part. In this part, we ask ourselves what kind of visualization is the most suitable for our case, and how to make graphs using pie chart. To find the most suitable kind of graph to show our data, we must know what our needs are being investors. Since we're here to find out which region should we invest, our biggest demand is comparing the prospect of every region. But what kind of graph can show the comparisons the best? Obviously, the bar graph is the most suitable one, because they can compare the data intuitively with the different heights of the bars. Then, how to use pie chart to make a bar graph of the growth rates of every region's photovoltaic power generation for the whole 4 years. First, we still need to import the tool packages, and except for the pandas to do the math, we also need to import Plotly for the visualization part. Then, same as the last code, we also need to let the computer access and read the data, calculate the growth rate, and sort them into order this time. Then, we need to set the bars by arranging the variables to represent x and y axis, and to set the labels of the growth rates for every bars. And then, set the layout by adding titles, colors of the bars, and their sizes. Finally, show the graph. By this process, we got the output. As you can see, this bar graph shows the growth rate of photovoltaic power generation of each region over 4 years and arrange them into a descending order, so we can have a very intuitive comparison of the data and to make our choice to invest. After visualizing the past data, we as investors also want to see if the regions could have a constant progress by the end of 2025, so we want to predict the future data. However, how can we predict, and what are the limitations? We believe the only thing we can do is to use the past data to predict the future. With our analysis of the growth rate from the last 4 years, we could probably use their averages to hypothesize the growth rate of photovoltaic power generation from 2024 to 2025. And again, by using pie chart, we could calculate the averages. Still, import the package and read the dataset. Rearrange the data by setting columns and rows. Calculate the growth rate of photovoltaic power generation between each 2 years and calculate their means by the pandas function. And print out the predicted data. Finally, we had the output of the averages of the growth rate for each region in the past 4 years. And we predicted that 2025 growth rate would probably follow this tendency, with the Yunnan having an average growth rate about 120%, being the champion. However, what are the limitations and potential inaccuracies of this prediction method? Changes are always going on, So it is not that scientific to simply predict the future growth rate using the averages. For example, maybe there are new policies to regulate or promote photovoltaic power generation industries in 2025, or our sample size is too small and maybe the natural conditions for 2025 will change, which will affect the amount of solar energy. These are just a few examples of the factors that might affect the future data. So we must consider more, and we need more data to make accurate predictions. So these are all our parts that associate with data. And now, with the growth rates we have, and Yunnan being the region with the fastest growth of photovoltaic power generation, we wonder what is the reason behind this result. There are some possible causes. First of all, Yunnan had a new policy within the past few years. According to the 2023 Yunnan Provincial Development and Reform Commission, the annual construction scale of photovoltaic power generation from 2023 to 2025 shall not be less than 15 million kilowatts. So, this probably can explain why the growth rate emerges from year 2022 to 2023 in Yunnan. Second, Yunnan's advantageous natural conditions also contributed to its growth rate. Yunnan has geographical features of high altitude, low latitude, and long hours of sunlight. All of these could lead to higher UV levels than many of the other regions. So, when more photovoltaic panels were built, the solar energy they absorbed could be way greater than other regions. Now, finally, let's make a conclusion and reflect on this project. In the data part, by collecting, cleaning, analyzing, visualizing, and predicting data, we know that if we are investors, we will surely invest Yunnan based on its fast development and high growth rates of photovoltaic power generation in these 4 years. That's all for our project. Thanks for watching.